So hello Mr. Lee, so this is Jack speaking and it's the third time for me to set up the draft to you. So I'll show you my new graph. So this is the graph I wanna illustrate to you. So this is point A plus H and FA plus H, and this is point A FA. So I wanna show this is the tangent line for the point AFA, and this is the secant line. So based on the limit method, I'll try to recall some formulas which we've learned last semester. So as is seen on the graph, uh, actually the point A plus H is the same as the point B. So but right now, so we just assume that H is an absolute value, but in my graph, the H should be a negative number, because if H is a positive number, this point over here should be moved to like maybe over here to the right of a point. So in my graph, the value of H should be negative, but in any cases, if H is positive, then this point will move to the right, and if H will be increasingly negative, so this point will increasingly move to the left. So this is one facet I want to explain. So for that, I wanna show like some show the relevance between the secant line and the tangent line. So as is seen to all, if we clearly identify the A plus H point to approach A point, this secant line should be increasingly approach the tangent line, and if we wanna get point A, we should let the slope of the secant line to equal to the actually it's have the same point to the slope of the tangent line. So I'll show you another picture. Yeah, so this the first step is the formula for the secant line. So I just put the A plus H in it, which is relating to my graph. So finally we get this answer f h a plus h minus fa and divide h. But moreover, in this graph, if a plus h should approach to a, h should be increasingly close to 0, as is known to all. So the last step is the limit formula with this function as is seen above, uh, with the fact that the limit cause h approach 0. So afterwards, I'm about to talk about some unusual cases that we cannot use the limit formula to identify like the slope of tangent. So that in this graph, we can see that there's a vertical asymptote over here. So if I just try that x approach 0 over here, this is 0 point. So I can got that 1, 2, 3, 4, the fx, which is the y value, should equals 4 over here. Yeah, the graph is a little bit rough, so never mind, sir. We can see that from the preceding and the following, from the left to the right to the point, and from the right to the left to the point. Both of the sign is close to is try to get close to the point 4. So over here, by the time x is like approach 0, so the y value should be 4. Nonetheless, let's go to the right side. If the x approaches 4 over here, approach 4, yeah. But as I demonstrated before, by the time we wanna get the fx value, we should, and with the limit formula, we should make sure that the slope of the secant will be equal to the slope of tangent at one point. So over here, we cannot see any points that is the same on a, by the time x is 4, because there is a vertical asymptote, so there's no points, no identical points between them. So this case, which y value should does not exist exactly. So after all the explanation, yeah, the chief point for me to like interpret all the stuffs is, if we use the limit formula, the let a plus h this point approaches a. First of all, we should make sure that h is approached 0 increasingly, and the second step for us to be mentioned is that the slope of the secant should increasingly like until it is the same as the slope of tangent, so that we can use the limit formula to calculate the slope of tangent for sure. So that's pretty much it of my presentation of the video essay. Thanks for watching, sir. Have a good day.